What we have here is the area, find the area bounded by a region closed by the curve y equals x squared minus 3x plus 3 and the line y equals 2x minus 1. Just going to give you a brief thing about, like, this part in itself technically has a bit about the line in it. Y equals mx plus c. Can anybody tell me what's the slope of this line? And 2 goes diagonal right up, doesn't it? So when I'm drawing a sketch of this graph, okay, so I'm going to just draw a quick sketch to see where I'm at. The first thing I'm going to do to try and sketch this graph is I'm going to find out where does the curve hit the x-axis. What's the general rule about the x-axis? Y equals 0. 0 equals x squared minus 3x plus 3. Now, I'm in the unfortunate position that this is going to be a minus b formula. Okay? And to do the minus b formula, have we ever done integration with the minus b form with decimals before? Probably not. So what I'm going to do is I'm just going to take a quick gamble here. That I'm just going to draw it, and I'm going to sort of almost guess that one of them's on the left and one of them's on the right. You'll find that actually doesn't matter in a minute. Now I'm then going to draw my line. I don't know. The line could be here. It could be here. I am too sure, but it's just a general guideline more than anything. So I'm just going to draw that up there. Now what I would really like to know is where do these 2 points meet? Okay? So where did they meet? Now, I suppose for what would be a really handy thing to do is you have the function in your calculator. I'm going to use my calculator function to find roughly where it crosses the x-axis. So let me show you, right? So mode, table, f of x equals x squared minus 3x plus 3, and then we go to minus 4, and then we're going to go to 6, then we're going to press equals. Now look at this, guys, okay? At the moment it's really high, isn't it? And then when does it cross the x-axis? It's still above the x-axis, and now all of a sudden, wait.
30.
Yeah, right. See in between 1 and 2. Okay? I almost think that this one actually doesn't cross the x-axis. Let's find out. If it doesn't cross the x-axis, what should we get? A maths error when we sorry guys, my it's acting up for a minute. C equals 3, okay? So look, we're just going quickly to the minus b formula after all, because that didn't really help at all. So what we're going to get is minus 3 is plus 3, plus or minus the square root of b squared. B squared is going to be 9, minus 4, ac. Now what do we know about that square root sign then? It's going to be the square root of a minus number. What happens when it's the square root of a minus number? Error. And because it's an error, it means that your graph never ever crossed the x-axis. So this is one of these questions where it doesn't actually cross the x-axis at all. Yes, Carl? Right, please. So we know it crosses up. So what we're going to do next is, we know we don't have to worry about the x-axis now. What we should probably worry about is where do the lines intersect each other. So how do you find out where the line? How do you find out where the curve intersects the line? Can anybody tell me? How do you find out where the curve intersects the line?
Let them graph equal to...
Let the y values equal each other. Because the y values are the same when the points are the same. So what we're going to get is 2x minus 1 equals what's x squared plus 3x, is it? Minus 3x plus 3. So look what happens here. I'm going to move it over. And I'm going to get x squared minus 5x. And then it's going to be plus 4. Now we're going to press the equal sign here. Going to solve that. We're going to get x minus 4, x minus 1 equals 0. Then we're going to get x equals 4 and x equals 1. So we can actually now understand that it's actually the curve intersects the line on the same half of the x-axis. So the graph looks more like this here. Has everybody understood? Now, we now have to go through the problem of how do we get the area? Okay? How do we find the area of this part here? And how do we find that area? Now here's what I'm going to do. the first thing I'm going to do is I'm going to find the area underneath the line. What would the area underneath the line be?
Trapezium.
It's a trapezium, but once again we don't even have to worry about that because the integration will do it for us. So what I'm going to do is get this red area here. Everybody understand that? Red area is starting off. So how do you get the red area?
The equation of the line.
Equation of the line integrated from what's the limits again?
4 and 1.
4 and 1. So integrate the line from 4 to 1 dx. Now once we're all happy, that's the red area. What are we double counting? We're double counting the blue area. We need to take away the blue area. And what's the blue area? The blue area is the area underneath the curve, which is going to be minus 4, 1, and what's the area? What's the formula of the curve again? X squared minus 3x plus 3. Now, what's going to happen here, guys, is when you integrate this, what should happen is the following, okay? We're looking at this. Which one do you expect to be the bigger value? I'm expecting the area under the line to be the bigger value by a significant amount, so let's find out. It's going to be x squared minus x from 4 to 1, and then the other one, which I'll put in red, is going to be what's it, third x cubed, and then that's going to be an x squared there, but I need the 3 over 2 to last, so it's going to be minus 3 over 2 x squared, and then plus 3x. Okay, and that's gone from 4 to 1. Alright guys, let's integrate. Now, will somebody take charge of the blue one? Connor, you did the blue one, is it? Yeah. And who's doing the red one? Yeah, well, you did the red one for me, please. I'll chop them down now for you. So it's going to be 4 squared minus 4 minus bracket 1 squared minus 1. That's the blue one.
Blue one's 12.
The blue one turns out to be 12. We're expecting the red one to be a number smaller than 12. If it's not smaller than 12, we've made a mistake. So then we're going to a third 4 cubed. Sorry, 4 cubed, not 14 cubed. 4 cubed minus 3 over 2. 4 squared. Plus 3 times 4. And then it's going to be minus everything there. So it's going to be minus a third 1 cubed. Minus 3 over 2. 1 squared plus 3 times 1. Has anybody got that yet? It's a long one to do though, so I won't expect you to be too quick about it. Let me know when you have it. Okay guys, so the red one turns out to be 15 over 2. So it's going to be 12 minus 15 over 2. And what's the answer to that? 9 over 2.
Yeah. That's the answer.
Yeah. And that's the answer back to the book?
Yeah.
Good man. Right, well done guys. Good question there. Now, guys, so example would be this one here. Y equals x squared plus 1. Okay? Now, what I will tell you guys is it's the area enclosed by the curve. Okay? So what we have is the xy axis here. I could put this equation into my calculator if I wanted. So I could put this equation into the calculator and I could figure out where does it go. But I'm well enough experienced to know that it crosses at 0, 1. If that was a number 3, it crosses 0, 3. Okay, so it goes up like this. It's a U-shaper. How do I know it's a U-shaper?
Positive x squared.
Positive x squared. Worst comes to worst, your calculator will do it for you and tell you it's U-shaped. Now, we want the line equals 5. Okay, so the line y equals 5 is up here. And this is the line y equals 5 going directly across. It wants this area here and this area here. Okay? Now, they're symmetrical, do you understand? On both sides of the y-axis you're dealing with the same area, which is handy for us. Okay? So, what I know here is that this area is 1 and this area here is, this point is 0, 1 and this one is 0, 5. Replace x with 0 and you would have got y equals 1. It goes from 1 to 5. Now you're thinking, alright, this is a integration where the y-axis is pinned in, so you want y dx. You have to integrate that. We're going to integrate 1 to 5 and we have to figure out what y is on its own. Now, y equals x squared plus 1. So we can see that it's quite an easy integration. So there's actually nothing special there whatsoever. Okay? And that's it. It's going to be very easy from this point onwards. We're just going to get oh, sorry. No, I got my formula mixed up. It's x to y, isn't it? For the y-axis, sorry, excuse me. It's too easy. It's x to y. So guys, I had to get x on its own. So now it's going back to what we said earlier. So when I get x on its own, I'm going to get x squared equals, what does x squared equal? 1 minus y. Okay?
Minus 1 plus y.
1 minus y. Because of the, yeah.
1 minus 1. You're bringing the
Oh, sorry. X squared equals y minus 1, excuse me. Alright guys, now, let me show you, I'm going to show you about 2 or 3 different ways of doing this. I think you're best to know 2 or 3 different methods for the same question as opposed to me doing 3 different questions, okay? So, what we're going to get here is x equals the square root of y minus 1. Now, this here, okay, it's plus or minus technically speaking, isn't it? The minus version accounts for the left side and the plus version accounts for the right side. So if we just do the plus version and multiply our answer by 2, that's okay, isn't it? Because they're symmetrical. Now look at this. What's going to happen is we're going to change that into y minus 1 to the power of a half. Now, you've never done anything like this before. The key thing to remember is you're allowed to do this when the derivative is 1. Do you understand? If the derivative of whatever is in the brackets is 1, you're allowed to do it like you do a normal question. So for example, if I gave you x to the power of a half to integrate, you would tell me the answer is x to the power of 3 over 2, 2 over 3. Yeah? We're going to use the same logic here for this one, only because the derivative of what's in here is 1. If the derivative of what is in here is not 1, you're not allowed to do it. Do you understand? So if you're to differentiate y minus 1, it's only the y that gets differentiated, isn't it? And it'll turn into 1. Now let's do what we were talking about yesterday. We're going to put y minus 1 to the power of 3 over 2. And then we have to put the fraction in front of it, don't we? 2 over 3. And then we go from 5 to 1. Can I give 2 people 2 jobs? Can I have somebody on the calculator and somebody looking at the back of the book for the answer, please? Okay? So what we're going to get here is this. 2 over 3 bracket 5 minus 1 to the power of 3 over 2. Will somebody take care of that part? And then maybe somebody else can take part of the second part, which I'm pretty sure is going to be 0. So what's the answer here? Sorry? 32 over 3. Is that what it is here?
No, 16 over 3.
Oh, perfect. 16 over 3 is perfect. Because remember what I said earlier? We only took the plus version. We didn't take the minus version. So we technically only got this part here. This half here. And I said earlier, it's symmetrical. Which means multiply your answer by 2 and what happens? You get 32 over 3. Let me explain a different way of getting the same answer. Here's a different way of getting the same answer, guys. Okay? Ready? Shh. Different way, same answer. Okay? What I could suggest to you guys, if you aren't the biggest fan of the y's, okay, what you could do is this. You could then say, if y equals 5, do you understand if y equals 5? We want to find out the x value of these 2 points here. Do you see that? We want to find the x value of these 2 points here. So what we're going to do, I just got to get rid of that shaded region there for a minute. No longer applies, okay? So what we're going to do is this, guys. We're going to find out what is the x value. So if y equals 5, it then becomes 5 equals x squared plus 1. X squared therefore is going to equal 4. X equals plus or minus 2. This one here is going to be minus 2, and this one here is going to be plus 2. What I'm going to suggest is the following. I suggest we make a big rectangle. The big rectangle is going to be of base what? 1, 2, 3, 4. The rectangle has a length of 4. What's its height? 0 to 5. It's not drawn to scale, I'm afraid, but you get what I'm talking about. 4 multiplied by 5? 20. Okay? What I'm then going to do from this 20 is I'm now going to find the area of the curve bounded to the x-axis. By finding the area of the curve bounded to the x-axis, I can then take this answer away from 20 and I hope to achieve 32/3. Let's find out if that's the case. So, I'm integrating from 2 to minus 2. I'm going to integrate y dx. What's the y value again? X squared plus 1, isn't it? Dx. Integrate. We get a third x cubed. Third x cubed plus x. And would somebody be kind enough to do that on the calculator for me? So what we're going to get is we're going to get a third to the power 3 plus 2, take away a third minus 2 to the power 3, and then it's going to be minus 2 because plus minus 2 is minus 2. So once you get that on the calculator, please let me know what the answer is. Here's 28/3. Now please remember, we got to take this answer away from 20. What happens when we take it away from 20? 32/3. Two completely different methods, same answer. Okay? Yes? Okay. In question 22, the diagram shows how parts of the graph f of x equals 4x minus x squared. If the areas of the shaded regions are equal, this one here equals this one here. But what is area B, by the way? Area B is a negative area, isn't it? Because it's below the axis. So please remember, it's the modulus of area B equals area A. Okay, it's the modulus, because we've been told that area B should be a negative number when we get it. So we got to be quite careful about that when we do it. So guys, look at this. We're going to integrate, and what we're going to say is that this one here, from 0 to 4, everybody understand where I got 0 to 4 from?
Yeah.
Written here, isn't it? And that's going to equal the area of 4 to P of 4x minus x squared dx. And we're just going to put these in vertical lines just to cover ourselves, just in case the need arises for us to do this. So guys, look at this. Integrate. Now what we're going to get is 2x squared minus a third x cubed. Is everybody happy with the integration there? Okay. 4 to 0. Then you're going to integrate, I'll put it in a different colour. We're going to integrate this one, and we actually get the same thing. It's the same formula. From, what's it, 4 to 0, isn't it? 4 to, sorry, P to 4. Now, integrate away. Now, we're looking for us, the second part is going to be negative, so we're just going to get 2 times 4 squared minus a third 4 cubed. Does anybody know what that is? 32/3. 32/3 is therefore going to be equal to, now replace it with P, it's going to be 2P squared minus, that's a cubed. So it's going to be 2P squared minus 2P, it's a third P cubed. Okay, and then what's going to be after that? Take away, what's it going to be taken away? It's going to be taken away, same thing, isn't it? 32/3. Now stop there, okay? So what we're going to get is 32/3 equals the square root of, it's 2P squared minus a third P cubed minus 32/3. Okay, stop there for a minute. So guys, please remember that this is a positive area, and we're expecting whatever is in here to be minus 32/3. Because we're expecting it to be a minus number, what we're going to do is we're going to multiply what's inside the modulus sign by minus 1. So we're going to get 32/3 equals minus 2p squared plus 1/3 p cubed plus 32 over 3. Now look what happens now, lads. The 32 over 3 is cancelled. We now have a 1/3 p cubed minus 2p squared equals 0. Let's multiply everything by 3. P cubed minus 6p squared equals 0. Factorize p squared into p minus 6 equals 0. Either p squared equals 0, which it cannot be, or p minus 6 equals 0, releasing p equals 6. The following questions. If y equals x cubed, express x as a function of y. X is therefore equal to the cube root of y. X equals y to the power of a third. Example, let's minimize this down. X cubed equals 27. If I want to find out what x is, I can put this into my calculator and it will tell me the answer is 3. If you bring a power over the other side, you put it into the power position over the other side and you turn it upside down. Works every time. Now that we have that sorted out, the region bound by the curve y equals x cubed and the line y equals 8 is divided into two regions of equal area. A1 equals A2. A1 and A2 are both positive, aren't they? It'd be negative if it was over the other side, but it's not. So we don't have to worry about any modulus tricks this time around. Okay? So now that we have that done, what you're then going to look at is this, okay? Show that k to the power 4 is 512. So we're going to say it's the integral from, this is y equals 0. So the integral from y equals k to 0 of y to the power of third dy. Remember, it's x dy this time, isn't it? Because it's into the y-axis. And that's going to equal the integral from 8 top k on the bottom, y to the third dy. Integrate both sides. What happens when you integrate y to the power of third? Yes, Simon?
No, I don't understand where you got that.
Okay, guys. So, both sections are separate to each other. Let's integrate. We're going to get y to the power of 4 over 3. And then we're going to have to get 3 over 4 in front of that to balance it out. Then we have k0. And then we have the same thing over here. Now, will somebody be really quick on the calculator for me here, please? What I need you to be quick on is, I need you to, what I'd like you to do is this. I'd like you to put in, it's going to be 3 over 4, k to the power of 4 over 3. Second one's going to be 0, nothing to worry about. It's the one after this. It's 3 to the power of 4, 8 to the power of 4 over 3 is the one I really want you to calculate for me.
12.
Is it 12?
Yeah.
Okay, so it's 12. So that there is 12. I'm going to bring this over the other side, and it's going to be 6 over 4, k to the 4 over 3. Now guys, here's what I want to do. I want us to multiply by 4, and then divide by 6. Are you sure it's 12, by the way, yeah? Okay.
It is 12.
Yeah, so multiply by 4, divide by 6, what do we get?
8.
8. Okay? Now, I want to find out what k4 is. Just 1 second. k4 to the power of a third is 4 over 3. Would you agree with that?
Yeah.
Now, how'd you get rid of a third? We did it earlier. You turn it upside down on the other side. What's 8 to the power of 3? I won't have time for it. No, I won't have time for it. K to the power of 4 is what? 512. 512. Sorry, Simon.